Hey, Rani here. Shall we make a game? Now, let's bring this up. Yes, we're still working on this damned nav mesh system. I swear it will be worth it eventually when it's built and we can actually do interesting things with it. However, I had a bit of a thought about the way I'm currently doing things, and I kind of realized I was actually going slightly down the wrong path. Now, one of the things is, right, is say you have a nav mesh like this. Looks like a croissant. That's making me hungry. So you have another mesh like this. You're starting here, and then in a single frame, you're moving all the way to here. Well, you're not just you're then having to kind of like walk through the kind of maze of triangles. And in a situation like that, simple situation like that, having the iteration be done in kind of like a single place is kind of fine, as long as you get your final position and you get your final, nav mesh triangle ID. All's good. However, in the real world, when it comes to making games, that isn't really going to work. So for example, what if I try to move from there, say there to there? Well, you cross one nav mesh edge, fine, no problem. Then you hit this wall, and then we reproject your position along this wall, and you don't have to start to do all sorts of, you might want to say play an animation when you to hear, make a sound effect or something like that. And I've been thinking about a few different ways of doing this. Like currently, if I just bring up the code to do this, when you, not check line of travel, not that one. When you do things like sliding collision, it actually has this iteration loop in here where it goes, it crosses one line, crosses the next line, and it can go up to 10 times. But it might not always be what you want. And also, if you have, say, a situation like this, say you have, some ground tiles like this, and then you do a motion like this, you actually want, generally in games, you want to do kind of like an airborne collision check here, and then do sliding collision against the surface, but kind of follow it round because you're then on the floor. So you want to, you want some kind of discrete action to happen here where it's able to play like a clunk sound effect, but then it'll kind of follow the floor along. And what this kind of suggests to me is that this iteration loop shouldn't be in here. Nav meshes should provide a huge library of tools to do things like sliding collision stuck to the ground, non-sliding collision, line of sight checks, but they shouldn't be doing the looping for you because there is so much kind of context that is lost about what happened during a collision if you're not in direct control of it. So, that means this entire section of API needs rethinking. The other thing that I realized I colossally messed up is that nav meshes have triangles in this. That's not how nav meshes are meant to work. It's just not. That's just not how they're supposed to work at all. They're supposed to use convex polygons, which could be triangles, but not necessarily triangles. So I kind of colossally messed up. So I've actually got a lot of rework to do on this before it's really usable for real games, which is annoying, but we'll deal with it, I guess. So I'm likely going to be working on this part of the engine until the end of this stream, which is annoying because I'm sure it's dull as all heck to watch. It's dull as all heck to work on, but it's so critical to making games with this engine that I can't really skip it. I can't really just ignore it. Oh yeah, and actually, I just thought of another thing. Not only, just to go back to this, one of the things I've got in here, the concept of kind of attaching agents to a nav mesh. And one of the things with that is, just to kind of skip back to that, is that you probably don't want it to happen while the character's airborne. So if you've got a platform like this, and you've got your character up here, you probably don't want movement to this platform to move the character unless they're on it. So even though the character might be within the bounds of this nav mesh, they'll be within the kind of planes of it, the attachment shouldn't automatically happen. And there's a lot of complexity to this. There's a lot of things where maybe this kind of agents component I've written, maybe that's actually wrong. Maybe that shouldn't be there because It's trying to generalize something that isn't generalizable. Okay. Now, with all that in mind, I'm actually going to scrap this because and I'm going to keep the line of travel. And today, what I'm going to do is I'm going to see if I can swap it over from using triangle to generic kind of generic sort of polygons. So that's going to be fun. Get rid of that. Get rid of that. Actually, we're not going to have that not triangle edge at all because we're going to be using an index and we're going to have any number. Okay. Get rid of this for now. And do I still have in here? Yes, I still have that in there. We've still got the agent and gravity in here, so that's fine. Let's just make sure we can still build this. And if we can, I'm going to commit that and then start doing my chaotic rework into a non-triangular system. Oh, what doesn't it like here? Oh, I didn't actually save my changes before I tried to do a build, so it was trying to build using half-finished code. Not that any of this is really finished. And we don't use less triangles, that's fine. And I was halfway through something here. Oh yeah, I was going to make it so when you click on the background, it selected the point in 3D space, but I never got that far. Okay. Oh, actually, that could be really good for testing if I had the ability to select a point in 3D space. Yeah, so I was also thinking about a bit of a rework of how cameras work. At the moment, we only have one global camera, and that's actually not quite right. It means we'll never be able to have split screen modes. But I'm like, is a camera a component or is it not a component? And the reason I didn't put it in as a component originally is that the transforms are kind of backwards for a camera because you're, if you move the camera to the right 4 meters, what you're actually doing is moving the scene to the left 4 meters. And that's kind of the opposite of how components and entities worked up until now. However, because we now, because we're going to be having both the forward and inverse transform of each object stored, so you can do things like, say, reproject points and stuff like that. That means that we'll have the data we need for a camera anyway. Something I need to sort out for that to be possible, though, is in this matrix file here. I have separate model and view functions, and while the model function takes in a scale, the view one doesn't. So I'm going to have to dig up the project that I stole these from, because that project did have test coverage. And, when I say stole, is my own code. So I'm pointing that out first of all. So reused from is perhaps the better term than stole. And I need to basically put the scale factor onto this so that we can have one sort of, transform go both into a forwards and an inverse transform. That should be quite easy to do. Okay, yep, that's good. We added a second object here, so we're kind of expecting that was going to be to demonstrate where you were clicking. Okay, so that's still working. Let's just commit this as is, and we can come back and figure it out later. So what I added here was an as untested line of travel check function. Okay, and now we destroy everything pretty much. We'll find every mention of triangles in here. Okay, I think that'll do what I want. For each edge of the polygon, the normal, which must be the normal of the plane, which must be crossed to exit over that edge. If I just keep writing the word, const everywhere, it'll probably work, right? Just remove them as they cause problems. Okay, for each vertex of the polygon, the normal of the, a normal pointing from its surface along the line of intersection between its two neighboring edges exit planes. There we go. There we go. I think that makes sense. It's one of those things that's really weird and abstract and doesn't really have a real world analog. And I'm like, how did this idea actually enter my brain? Like, to build it like this? Where did this come from? I'll do like a bit of a deep dive at some point and figure out where this idea even came from, because it's a bit weird. For each edge of the polygon, and then we're pointing. Oh, hang on, it's not a normal though, is it? A vector pointing from the first to the second vertex of length 1 divided by of magnitude. There we go. That'll do. And oh, I never commented this. I guess it was obvious. Okay, at the moment we have this sort of structure where we're kind of, you know what, I'm going to get rid of this entire struct. I'm going to sort of inline it. I'm feeling dangerous. Because I'm kind of appreciating that there's going to be many different access patterns over this data structure. Okay, so for each polygon, the indices of the polygons for each edge therein. I'm going to have to store how many edges each polygon has as well. Okay, that's fine. For each polygon, for each edge therein, the index of the polygon found by crossing it, or okay, there we go. Yep, that makes sense, I guess. And let's write the word constant another 15 times, just so we definitely get it. And then we need to store, the number of polygons. And let's go signed, because I am growing to hate unsigned integers after using them for a bit. For each polygon, the number of edges. Sorry, vertex counts. Actually, they're one and the same, aren't they? Yeah, like a triangle, 3 vertices, 3 edges. Okay, for each polygon, for each edge. Okay, that needs to be a Like that. We'll figure out which one we need to remove later. What's happening with the syntax highlighting here? It's like this one letter at the end of the word is a different color. Oh, I've had this in multiple IDEs now. I've had it in JetBrains IDE multiple times. Okay, let's keep searching for the word triangle, polygon. For each polygon, for each vertex therein. Location on the X, Y, and Z/Z axis. Okay, all right. And again, I need to change that into more like this. Can I write the word const after that? Let's just write the word const a few more times. I'm sure that isn't going to anger the compiler at all. Okay, for each polygon, for each edge therein. Each polygon, each edge therein. Okay, that's fine. That's fine. I was just having a bit of a think there. Yeah. Hang on, I've written this wrong. Ah. Okay, I should probably explain in this what the structure actually represents, because if most people hear navigation mesh, they're not thinking like a graph of infinite prisms reaching into the heavens. Each polygon within is convex and planar, has a planar surface with infinitely tall prism extending. So I would say upwards from the surface, bearing in mind this could be an upside down polygon away from the surface. The walls of the prism represent planes which can be crossed to enter neighboring polygons. There we go, that's technically correct. For each polygon, for each edge within. Therein, what does that word mean? Yeah, that'll do. Hang on, within versus therein. I think it should be within, not therein. Yeah, I remember when I first wrote this code, being like, it kind of works, but I'm pretty sure this isn't gonna be what I stick with. It's gonna be the entity component system. That's gone through like 10, 15 revisions before it's kind of stuck where it mostly stuck where it is. I'm still reworking parts of it. Right, so almost there. And then we can start reworking the importer to actually generate this new format. We're gonna have to dummy out all the code that interacts with this. And believe it or not, we're actually probably going to be removing a lot of code because rather than having like special cases to handle like edge A, B, C, we're instead just going to have like a loop over the edges, and then that means that code's kind of reusable. There are going to be complexities when it comes to say like all the cases where you can be over two edges at once, but we'll figure it out. In fact, what I might make it do initially, actually, yeah, I'll make it. Will I? Will I make it still triangulate? I'm not sure. No, I was wondering if maybe I could like switch the code over to doing generic kind of iteration, and then just change the code that generates what comes in as generating polygons rather than triangles. So I don't really see any benefit to that. Okay, that's our pretty much complete straight up rewrite of that. All right, so next up we want to get this kind of layer thing rewritten. That's going to be the next thing. Let's comment out all this code to do with collision because this is all going to be very, very broken by what we just did. All this work. It'll be worth it though. Be worth it though, I swear. We'll have much more of an idea of how to deal with these problems. Be much more flexible. So yeah, this needs to change. This is currently all dealing with like yeah, A's and B's and stuff. Right. Okay, this needs to change like a lot. Okay. Yeah, this needs to be more of a generic case. Okay. Wow, I've made a lot of work for myself, haven't I? Okay, yeah, for now, I'm just going to get this kind of building again. It's not going to build probably until it, I'll be surprised if it builds by the end of this end of the stream. Okay, yep, we can get rid of that. Thank you very much. And so just following the errors, just write constant everywhere and basically remove it wherever it raises an error about it. I'll internalize the rule eventually on what different consts mean in different places. Okay, didn't like that. Why doesn't it like that? Oh. Oh yeah, I didn't rename it. Something I'm going to be working towards as well with the kind of planned engine rewrite is to it's a standardize on, it's kind of like a vector type you can reuse everywhere. I think that'll come with a lot of benefits. I'm gonna get rid of this navigation mesh agent class because I feel like it's a mistake. It's one of the things that you just don't know until you built it and tried it and you go, oh, that doesn't actually work in this situation, that situation, the other situation. Oh, that was kind of a mistake, huh? Oh, it's not happy with a lot of things. Okay, so... I think I've got in the advanced helper. I think I have in here a bit where, yeah, it calls into the navigation mesh component here to do collision. We can turn that off now. Okay, we're now onto the rendering code. So this basically needs completely rewriting to deal with the fact that we're, yeah, that we're changing how polygons work. So I'm just going to grab this and I'm just going to throw it away. Put it in here temporarily and then we can kind of build it back together as we go. Now this does mean we're no longer going to have that really nice lighting, like kind of shading where you can see like where the A, B and C polygons, so vertices are, because there isn't going to be one, but not the end of the world. So I might actually add a helper for doing 3D lines. I think that'd be really good because like we're really getting commonly into the situation we're going like draw a line between this point and this point in 3D space, and there's just this very annoying repetitive logic of like, you know, doing this. Maybe a line components? No, about that. Feels like it's something that shouldn't really be commonly used. Something else I'm actually reconsidering is namespacing. Because at the moment I'm doing like a bunch of like namespacing, like having like an engine name prefix and then, you know, putting like the name. And it's resulting in these names being absolutely gigantic. And generally that makes sense in most code bases because, you know, you're coexisting with all these libraries you're pulling in and stuff like that. And, you know, they have their own prefixes to, you know, reduce the chance of collisions. But I'm like, the whole point of this project is that there are no dependencies in here. So how much do I really get for that? And is it actually better to just write a bunch of functions and just, you know, use my own judgment? I think that's probably going to get better results. So let's go back into the navigation mesh and see what we've got. So we've got the polygon count. Okay, and then we've got this. And then we've got this. And now we're going to iterate over the polygons. And yeah, I'm gonna try and like fix my long variable name itis, I guess I'll call it. It's a real problem. It's, you know, making this code really hard to read. I wonder if I even need kind of like, you know, polygon in here because yeah, I mean, I guess that navmesh is just a collection of polygons. It doesn't really need polygon prefixing every single one of these variable names. That's just annoying. Okay, so we're going to use we're going to get the number of vertices and then we're going to iterate over them. So yeah, so it might make sense to have like polygon count there. So it's one of the things where like trying to use your own judgment, not trying to be like, do I need to say it's a polygon count? Well, in this case, I'm counting multiple things, so maybe. Okay, so we have number of vertices. We're now going to iterate over them. We're going to special case the one because it obviously wraps around. Oh, actually, maybe not. This is where we write that handy helper function. Yeah, some other things I was thinking about redesigning is images, because you kind of get stuck in this kind of awkward case where some of them have depth, some of them don't, so they're actually very, very different. And you also end up in a situation where some of them are mutable, some of them aren't. So I'm like, it's almost like you've got two different use cases. I should probably have like a frame buffer and like a like sort of like a sprite class. They'd be structured with very different things because they're just used for different things. And writing code that's generic across both is actually kind of a pain. So yeah, so we're going to iterate over the vertices. And I guess I could just keep a reference to the previous vertex here. Yeah, I'll do that. And I need to look up C const. I need to remember which way around these are. Here we go, here it is. Okay, so what we want here is a pointer to data that we can't change, but we can change which data it points to. Okay, we want that one. Okay. Okay, so basically a loop through, we're keeping track of where the previous vertex location was, and we're initializing that with the end of the list, so we'll get that nice loop back around. We get a nice closed loop without any further weird logic. So next up we can do that, nice and simple. And then after the loop, we update the previous, do the next. And this is where we draw our line. We just need to specify where from and which color. So yeah, this might end up ascending to a, a more generic library function at some point. There it is. That's what we need. Yeah. So basically we basically transform the origin, transform the destination. If they're both visible, like they're not clipping through the camera or something, that's when we kind of that's when we render a line. You know what else I'm probably going to do in the kind of like sort of engine overhaul? I'm going to get rid of most of these types. You never use 64-bit integers or 64-bit floats. They're just not useful in games, generally speaking. Not the games that scale, anyway. Okay, yeah, we can skip transforming the second point if the first one's bad. That's good. That's good. And then if our destination is good too, that's when we draw the line in 2D using the, we've turned the 3D line into a 2D line. So yeah, origin row, origin column, origin color. Very glad I added this helper. And then the image. I need to be careful though calling things origin destination because kind of got source and destination in kind of like image processing terms. I don't know how to deal with that. Another time maybe. Previous application. Let's go for a red. To a green. That'll do. So should work, I think. Oh no, it's not happy with that. What was it not happy about? Oh yeah, I said this was mutable. It's obviously not. Yeah, we're not going to be modifying any of this actually. And now it's talking about now it's talking about the fact that indices are unsigned for some reason. I should really just sign them. Should I just do that now? What could possibly break from doing this? Easy. Oh no, I broke everything. Who could see that coming? Get rid of that too. Oh no, I've really annoyed everything, haven't I? Why did I make that change? Why did I think that was a good idea? Oh no, I've wrecked everything. Oh no. Oh well, the code base will be cleaner for it, I swear. I'm just coming in like a wrecking ball today. Every single piece of code is going to change today. Every single one of them. Think about it, like indices should really be a primitive. I wonder why I didn't do that. Anyway. Oh, this is at the root. I thought this was in like the... Oh, I thought this is a subdirectory of some kind. Come on, you can do it. Oh, it's actually going to build. Okay, I wasn't really prepared for that. Well, it's probably not because it's going to reach the bit with the... What? Oh, I was going to say, how did it get that far? No, that's expected. That's expected. What was this? Oh yeah, this is a old layering code, so I'll keep that around. Okay, we're going to want to get obj to C, and we're going to want to yeah, everything to do with triangles in here needs to change pretty much. I see, I've got all this in here that needs to now be scrapped, doesn't it? So this entire section is dealing with turning polygons into triangles. So I can get rid of basically all of that. Yeah, we already have a list of polygons. We don't need any of that. Yeah, that's good. That's good. I'm happy with that. So where were we using this? Why were we making this list? What was it for? Oh, I guess it was kind of useful, I suppose. It's all getting complicated now. I'm coming like a wrecking ball and just changing everything after it's already been built. Okay. Let's bring up that navigation mesh file again. And so we need to store the number of polygons, number of vertices within each polygon, for each polygon within each within. That should actually be a constant. That should be a pointer to a pointer. It might be backed by a single array, but that should be a pointer to a pointer just so we can skip to the right part of the array. We're having to count all the edges of the bits before. So I should have face indices length. There we go. And I believe I can use, I can again use the number of face indices to record the neighbors, because there's one index per vertex, right? Because like say yeah, that's right. And there's always going to be one edge per vertex, so that's right. I'm also going to double check in here, do double check that polygons are planar, to do double check that they are convex. Yeah. I mean, we can leave those in as to-dos. I mean, like, from a level design perspective, we know to do that anyway. Should they be called faces, not polygons? I think they should. Yeah, because that way they'd be consistent with the format we're kind of basing this on. Kind of annoying, but we'll figure it out. So this remaining streams are probably going to be hella dull, just because I'm trying to get this trying to get this damn thing to kind of fit together and work properly. And I've basically given up on actually, even having a remotely completable game at this point. I'm trying to build something I can use to make future games. That's probably good. Okay. And then rather than polygon, we're going face, 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 face. Oh, didn't mean to select multiple lines there, but I did. Okay, yeah, this is an important check we need to keep in here. Okay. So we need to loop over the... Oh, we can get rid of all of this. Get rid of this. Okay, all right, we're good, we're good. So we need to store the number of faces. Hang on. Hang on. Hang on, I've gotten confused. Where are we storing how many vertices are in each face? I've actually forgotten. There you go, face lengths. That's not at all confusing. Great job, past me. Okay, so at this point we can just do our simple double check to make sure that there's no overlapping faces. If I get this done today, it'd be a miracle. Okay, so now we have a list of first and second vertices. We're going to get a pointer to, we're going to get a pointer here. So again, this needs to look at the previous implementation, see where I'm getting that data from. Oh. Okay, I need to keep a running counter of where we've got to in the face list. Man, this is getting confusing. Oh no. Yeah. So, because we're actually storing all of the faces in a big, long list, as we're working through, we actually need to keep track of, yeah, 'cause I might be working on a polygon with, like, say, 4 sides, and it might be the 30th polygon. Without going back and recounting every polygon before, you don't know how far into that list of vertices you actually are. So I'm just going to keep track of it as I kind of scroll through. Bit ugly and dirty, but eh. Um, that's right. Yeah, that was it. Well, things a lot of the naming has kind of leaked into this file from the OBJ files it's based on, and it's getting confusing because they just call them vertices, whereas I call them vertex locations. Now, I did as a helper, didn't I, to determine whether two vertices are in the same place. What's this talking about? Oh yeah, I need to take the pointer, not the... And we need to basically reuse our failure message from before. I think I called them degenerate, didn't I? Yes. Hey, navigation mesh polygon is degenerate. Okay, so at this point, if we got through all of this, we know that we're probably good. I guess we could be calculating other stuff as we go, like say the normals from say, you know, A to B and whatever. Yeah, actually no, I think we're calculating the normals first, because we need the normals to calculate a lot of other things. Okay, so we know that it's not a degenerate polygon now. Now we're looking for other faces that have the same, that kind of like share an edge but flipped. That said, I think it's not just whether it's flipped, isn't it? Also whether it's... Hang on. I'm just going to grab all the cases here and I'm just going to have a look through them and try and remember how this logic ended up working. I remember having an issue with this. I think it could be flipped or unflipped. Let's just... let's see here. So we've got A, B, B, A. Oops. Okay, what else are we comparing A, B to? Yeah, so hang on, let me just draw this up, because I'm trying to remember how this worked. So let's say we've got a triangle like this. Right. Now, we have a triangle like this, and it might be A, B. I'm trying to remember why I have 9 cases here. Hang on, let me just decrustify this a bit, maybe it'd be a bit more clear. That hasn't really helped at all, has it? Okay, so A is B and B is A. Right, okay. So we need to go for all 3 possible combinations. Okay, right. I'm sure this isn't going to work first time around. I'm optimistic like that. So yeah, we now want to iterate over all of the other we want to iterate over all other polygons or faces in the nav mesh, and if they share edges, that's when we want to join them up. And we're going to do this same trick in here just to keep track. So I've got the pattern here. So we're going through A to C. And when we're comparing the one after, so it's like A, B, C, A, B, C, C, A, we're then comparing them to the opposite. Hang on, B, C, A, B, C, A, A, B, C. Oh, okay, right. So yeah, there is actually a nice bit of symmetry to this that we can take advantage of. I'm hoping this works. See, while I am throwing away code here, like the kind of learnings from it, I'm definitely holding on to. So it's not actually a complete waste of sort of effort building this in the first place. Yeah, I probably wouldn't have been able to see this pattern so easily if I hadn't thrown that code away in the first place. Okay, so it's actually only indices that we really want here. So we're going to do the same trick again, where we're basically, having like a sort of trailing index behind us that we're using to compare against quickly. Okay, that works. That works pretty good. Every reference to the first needs to become second, and we're just going to do the same trick here. And at that point, Oh, I've just spotted some copy paste I didn't fix. Okay, so now we have the, if we're kind of like walking around these two triangles, we now have this one and this one and this one and this one. So now we just need to compare them. So I think we have to test them both ways around, right? No, we don't. So if the previous first index is the next second index and the previous second index is the next first index, then we know we have a match. I think. Oh no, that's incomprehensible. That's great. Okay, so hang on. I'm actually going to mix these up a bit so that I'm iterating through the we can merge those two loops together. Should we do it? Don't know. But we're going to do it anyway. Okay. Yeah, this loop is going to now contain this loop. And I had this here. Yeah, so we've got the first face. And then I'm going to iterate through each. No, wait. We have the. Oh my god, I'm getting so confused here. Right. Okay, yeah, we're basically mixing two loops together here and making ourselves really confused, which is great. That's what we want. So I want to grab the next first index, which is going to be. We can actually grab it up here and reuse it for this. Oh my god, this is getting so confusing, and I'm here for it. I swear eventually, when this thing works, it'll be absolutely fantastic for building, simple games quickly, but my god, is it turning out to be a headache. Okay, that looks good. Oh yeah, this should actually exit as well. That'd be a good idea. At the moment it should go, yeah, there's an error. I'm not going to stop though. Okay, so at this point we know these two edges are shared, and we're going to have to store a integer here for, yeah. And we're calling these faces, not polygons. Okay, that's getting closer. So now we should have a list of... Oh, wait a minute, that's still wrong. Right, so now we should have... We've checked that all the polygons are not degenerate. We've then built a kind of like a quick lookup list to get an idea of how which edges connect to which edges, to which polygon, sorry. And now we calculate the surface normal. And I just need to make a note of the Wombashi. And rather than calling it match, let's call it neighbor. That makes way more sense. That'll be far clearer in future what that actually is. Yep, that's good. And so next step is, yeah, we need to calculate those. We need to calculate the surface normal. So the way we're going to do this is much like before. Basically going to grab the location of the first, second, and third vertices. We're going to do a cross product between them and get the up normal. In theory, we'd then be able to check that they're convex. Not going to bother with that for now. That's going to be a later thing. Okay, so we've now got our three coordinates, and then we're now going to take the difference between them. So I think I had normal between. Yes, I did. And then calculate the cross product. Surface normal, and then we just normalize it. Easy, easy. Okay. There's actually way less code than before because we're not special casing each edge. Look at all this code we had before. Like, imagine that, like how difficult it was to debug and find all the problems with it. This one will go either very right or very wrong. I'm going to take a pointer to our surface normal, which is going to be in face surface normals. First face index divided by 3. Yeah, that sounds about right. Okay, we no longer need this header like at all. Actually, we're going to need a different header though. Let's see what we have in here. We have the vertex counts. We can probably start to write that in. We can actually write that in before this. So let's actually write this in right now. What's this index used for? Where's that going? I think the answer is it's not used. Yeah, it's not used. That's fine, get rid of it. Okay, filter out the header of navigation meshes, face vertex counts. And it's that type, that's good. And then after that we have the face indices which are being used for the neighbors. We can actually write that almost immediately after this. Let's just rename that to neighbors. And it's going to be an index array, that's good. We can write those in as we work our way down. We're still going to need them to do kind of like averaging of normals, to work out the kind of like, you know, the side normals and stuff. But most of this we can get rid of. Just move it into like a temporary file. And we're still getting source control anyway, so it's not like we've lost anything, even if we do lose everything, if that makes sense. Man, face length is a really, really poor choice of name because like it makes it sound like it's actually a measurement of 3D space, but it's just the quantity of things in it. I guess count is a much better term than length. Wow, I actually agree with PHP about something for once. Someone make note of the date. Okay, so next we're going to write out, where was it? Here it is. And we can write down here while we're calculating these, we can write the neighbor in there. How to write a navigation meshes neighbors. And we check the neighbor if it's -1. We need to write none, otherwise we write the number. Easy peasy. And let's change all these to face and see what it does. Very good. Okay, and next we're going to have a loop where it goes through and it outputs all the surface normals, I think. This will probably still fail. That's kind of expected though. But we should be able to have a look at what it's producing and make sure it makes sense to us. Wow, it's taking a while to build, huh? I was expecting it to crash by now. There we go. That's what I wanted to see. Okay. We're not taking a pointer. We're not supposed to be taking a pointer. You haven't used this function. I'm like, that's fine. We'll work at that later. Oh yeah, I've still got these to-dos in here. Yeah, one of the things I'm definitely going to be doing as I kind of rework this into kind of like, you know, a reusable engine is anywhere there's a to-do, it needs to be handled. Okay, so a navigation mesh face shares an edge with multiple other faces. Don't know if that's true. How do I disprove that? Ah, well, for a start off, I wasn't doing that. That's probably the cause. Yeah, I was using that thing where I kind of like trail a vertex behind. There we go. Yep, that works. That fixed it. Right, so where's our navigation mesh? There it is. Vertex counts. They're all 3. I'm going to go into I'm going to Blender, and I'm just going to I'll get rid of these 3 vertices first, and then I'm going to try these 2 quads. To be honest, there's a lot of classical mathematicians who'd probably be absolutely horrified by what on earth I'm doing here, because I barely know myself. Okay, let's rebuild that and let's see what that does. Okay, it's looking more like it. That is correctly carrying those over. And then the neighbors, those look plausible. Like most of the faces have no neighbors on edges, but then we've got an occasional one, and they look plausible. That looks like that might actually be working, which is a bit worrying, but let's carry on. So we've now got our surface normals, so we can write this in. We're going to need a separate loop for those, unfortunately, but we can do that. Header of its surface normals. Ah, the other thing is I'm actually going to need 2 arrays, because one of them is going to be, because like, I'm just going to have like this, you know, big long line of, you know, like, for example here, you know, I'm trying to think the best way of explaining this. I might have, yeah, except all my polygons have got different numbers of triangles, right? Sorry, edges. So I might have, say, you know, I might have a polygon with 4 vertices, one with 3 vertices, one with 5 vertices, and I want to be able to go, I'm after the stuff for the second polygon. I don't really care about how many things there are in here. So basically at that point, need kind of like a second array to sit in front of it and kind of point you to the, you know, the correct place in this array. Yeah. We'll figure that out. So again, we're going to be having a look at this and just make sure that what comes out the other end makes sense before we kind of carry on. Oh, actually. I don't actually really need to do like the multiple in one go, because it's just a big heap of axes. There you go. I was gonna say, you happy with that Visual Studio Code? You're taking a while. Okay, let's see what this does. So we're looking for vectors that mostly point along. Oh, I've used the wrong type name, but hang on, hang on. So that's a normal, 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 that's a normal. I suspect these might be upside down because that one's well, I don't think that's right in any case. Because these should mostly be pointing up. That one's pointing down. That one's pointing straight down, which definitely isn't a thing. Yeah, that's weird. So let's fix that incorrect type name first of all. Yeah, I mean, the engine kind of overhaul I'm looking to do, that would literally just be F32 because nothing is called F32 that I haven't written myself. Let's just put this back so we'll actually see it refresh and we edit. So when we run the import. And we take a look at this and figure out what I've done wrong. So I've done something wrong. So we're getting the first, second, and third. Ah, we're not multiplying by 3. Yeah, so we're basically getting, if you imagine that we have a, if we have like, in memory, we have kind of like, we have these vectors on various axes, and I was saying, get me the location of the second vector. And rather than going to, bx, I was going to AY because I wasn't multiplying by 3. So we're getting basically completely random numbers pretty much at the other end, which is why those normals are all over the place. Okay, let's have a look. That's mostly pointing up. That's sort of pointing up. Hang on, let me just split this over multiple lines. That looks more plausible. I still don't know if that's correct, but it looks more plausible. Wait, there's no negative numbers in there at all. That doesn't sound right. It's like not even one. Let's just have a look at this. Let's just pull, say, let's pull these two down a bit. And actually, let's go into normal. So that's now planar, and we can kind of twist it like that. That should give us a negative number. Oh, well, it would do if I hadn't edited the file. Make it again. It's not going to remake it. Damn it. I need to do a rebuild. Come on, computer, you can do it. You can do it. I don't see a negative number there, so something's definitely wrong with how I'm calculating these normals. So let's just let's get rid of every, oops. Let's get rid of every polygon except one known to be facing the right way, and then we can have a look at it and try and figure out what's wrong, where it's going wrong. This should build much more quickly. Oh wait, it is right. I was looking at the wrong list of, I was looking at the wrong list of numbers. Am I that stupid? I guess I am. Okay, let's put all the other polygons back in. Yeah, I wanted to be looking at these numbers, and let's just have a look at these again in detail. Yeah, those look way more plausible. They're all facing way more up, and some of them are facing left, some facing right. So those look about right. So what else do we need to write out? We need to write out their locations. And hey, you know what? I can do something kind of similar to what I did before, where I don't actually need to know anything about the so just took me a moment there, right? Yeah, we need to iterate over the faces, and then we need to iterate over the vertices within them. So that should be doable. What did I call it? I called it the face index offset, didn't I? Yeah, that's completely incomprehensible. What was I even thinking? No, wait. I don't need to do any of this. Ah! Okay. So now I fetch out the actual coordinate, which is in I'm vertices. Oh, I'm starting to fade a bit. Was it that one? Is that the one I'm after? I don't remember. Ah! Okay, we're almost there. Okay, let's see what that does. Oh, it doesn't like that. Here we go. Let's see if that produces some plausible looking numbers. So we're basically looking for things that are roughly in the coordinate space of this. Well, those are numbers. Let's just check them. Because I don't think those are right. They don't look right. 602, 1.5. I suspect these are coming out of other objects in the scene. Let me just check. Oh no. What have I done to my code base? So that's definitely not the right number, so that's definitely wrong. Uh, oh, I need to multiply by 3. Again, making the same mistake. Forgetting that they're three-dimensional coordinates. I should make a 1D game instead. That sounds way more feasible. So 217 is... Hey, that's the vertex there. That's probably right then. Okay, that's good. All right. Next up, we need to write the kind of like pointer array that kind of, well, points at the array we just made. Vertex locations, and the header of its vertex location remappings. There we go. That's what I'm going to call it. Remappings. Okay, so how is this going to work? So we basically need to keep track of the index we've sort of jumped to. Yeah. That's what we need. We need to get the number of edges, and we need to write out the exact position into that array, which should be quite easy to calculate. And I hope that pointers like this are something that you can do statically in C. I think they are. Be surprised if they're not. Okay, so now we want to get the number in this particular, I think it's face length. Yes, that's the one. So face index offset plus equals. Yeah, so basically we're working our way through the list of faces, and we're kind of counting the number of vertices in each one, and then we're making a quick sort of lookup from, I'm at polygon 5, where do the vertices start for that? Okay. Yeah, that should be handy in general. So what we're going to be writing out for this is a little bit more complex. It's going to be something like this. Pointer 2, and we're going to want more. We want to bring these in because we're referencing the name of something. And then we're going to have a face index offset. Let's see what that does. I didn't quite like that. Let's have a look. That doesn't look bad. Yeah, it's gone like, pointed to the first one, pointed to the fourth one. So that's correct because the first one has 4 vertices, and we're going to point to the 7th one because again the second one has 3. So that actually seems to be working. It's kind of ugly, the code it produces. I'm glad I'm machine generating that. But it doesn't like the pointers. It doesn't like the pointer type. What's it not happy with? Why doesn't it like that? Because it's saying that we can't initialize a const float Can't, so we can't initialize that from. So it's saying that we can't initialize. It seems to think, right, because what we're saying here is we have an array, so effectively a pointer, to a set of pointers, right? And we're initializing that. Oh, I see what the problem is. I've still got the remappings on here, so it's actually pointing to itself, which is wrong. That should fix it. Or it would if the terminal hadn't broken for basically no reason. Thank you. Thank you for the studio code. Appreciate it. Okay, that's good. That's good. So what else do we need to export? Let's go through to here. Got surface normal, the edge normals, edge intersection normals, and the edge coefficients. We need to calculate those realistically before we can export them. Yeah, okay, that's easy enough to do. Well, it is now we've done the hard work of figuring out how to do it. So we can collapse this. I'm not going to need this again, or this. So let's calculate the exit normals next. Face exit normals. And we're going to want one normal for each kind of edge, so that'll be correct. Okay. All right. Now we had to wait until we'd actually looped all the way through, and the reason we had to do that was that we needed to know the surface normals of both our side and the neighbor's side. So we had to wait until they'd all been calculated. So next up we can, we also need to know the neighbors. So we're going to iterate over the faces. How are we doing for time? Come up in the end. Kind of glad I'm doing this now, though. I wouldn't want to do this after I've written more code, depending upon them being triangular. So we have our face index, and oh, hang on. We don't actually care at this point. Oh, no, we do. I was thinking, like, we don't actually care how they're grouped into faces, but we still do because we still need these surface normals. So yeah, surface normal is face surface normals. So we have a face normal, and then we need to calculate the normal along, say, each vertex. So next up, we need to, kind of like we're doing it here, we need like the, vertex index and the previous one. We can get rid of first in every case, as we're only going to be iterating one triangle at a time now. That kind of like hairy bit where we're kind of like iterating the same array twice is not present. We need that for comparing two triangles to figure out if they align. Okay, so now we can go for, actually it's going to be edge indexes, not vertex indexes. And we can reset this to 0, and we're going to use it again. Right. Hang on. I'm thinking, hurts. Okay, so we're going to get the next index, which is going to be like that. Simple enough. And we're going to overwrite the previous index for the next index, just so we're not losing track of it. Right. So now we know exactly which vertices we are kind of tracing between. Okay, all right. So next up, we need to check. We need to check whether there's a neighbor over that edge. Okay, if there is a neighbor, we need to average their normals together. If there's not, we hang on, let's bring up the old code. The old code. Where's the bit for averages then? There it is. Yes, I actually scrolled right into it. So let's get a pointer to that array that we just made. Face exit normal and by 3. So now we know where we're going to be writing it to use later on, but we're also going to use it to we're going to use it to write it out at the same time. Okay. So if there's a neighbor, if there's not a neighbor, that is. Oh, we also need to calculate the normal between us. So I'm kind of just talking gibberish right now while I try and figure out what on earth I'm doing. Oh, it's actually not the index we need. It's actually the previous location. There you go. Yeah, previous. Yeah, we need the vertex locations. That's what we're actually using here. So, vertices. But it's called vertex because we're getting out of an OBJ file. So I'm getting into gibberish territory because I'm like trying to think faster than I can talk. Okay, so now we have the next and the previous location, and we can now get the normal between them. And we can actually use this for 2 different things. We can both write out the, we can calculate the coefficient thing we were talking about earlier. So I might do that in a separate pass. Yeah, I'm going to export the, what are they called? I've gone blank. The edge coefficients. I'm going to write those out now. And what do we actually call them in here? Oh, they're just called edge coefficients. Okay. So for now, I'm just going to comment all those out and also that. And I am just going to add in some code to write the edge coefficient here. So I think I have everything in here for, turn these off so I can find it. There you go, yeah, that's the one. Now, I think that's only going to be used in one place, so I might actually be able to take this out of here. And we know it can't be 0 because we've already checked the edges are non-degenerate. Right, and then I'm just going to write these out. Nice and simple. Don't really have a way of verifying these as the numbers are so strange. They're not like normals or anything I can really measure. But as long as it looks vaguely right, yeah, as long as we get numbers. Oh yeah, we're not currently using the face surface normal. We'll use that later. Come on, you can do it. Okay, that's looking good. Let's go back to our movie theater file. We're getting something that look like numbers. That's all I can really say, really, with regards to proving whether or not it works. And we're also going to put in a remapping table, just like we did before. Okay. And I think I just need to multiply it by 3 because... Yeah, I need to multiply it by 3 because they're 3-dimensional and there's 3 of them per vertex. Okay, let's see what that does. Does that build? So it's 0 and it's 12 because it's 3 times... Yeah, because we've got 4 vertices, 3 axes, so that's actually correct. So that's looking good. So next up, we need to calculate these face exit normals. Oh, I think I'm going to run out of time to actually finish this like complete rewrite of this function today. I was really hoping to get it on. You know, I might have time to just get it on screen. We'll see. Okay, so we've got our neighbor, we've got a surface normal. Okay, that should be good. That should be good. I think we're going to use this normal average in one place as well, so we can probably get rid of that. Yeah, let's get rid of that. Yeah, it made sense when we were doing the repetitive like A side, B side, C side stuff. We're not doing that anymore. Um, yeah, we need to go find the neighbor's surface normal as well. It's not super hard to do. Okay, we might be able to get this done today. We might be able to get this back on the screen today. Yeah, the main reason I'm doing this is that, you know, the whole kind of purpose. So the first thing is that in a lot of cases, it'll actually massively speed up searching the nav mesh for a path, because it means fewer actual polygons. Second thing is the paths it will take will tend to be more natural looking, because it won't be following kind of like, you know, the weird sort of zigzagging tessellations of the polygons on the floor. Of the triangles. It'd be able to, you know, say like cross a say a hexagonal room in one go. And if I want to make those changes, it makes sense to make them before I've written a ton of infrastructure around them. And this also means I can make the code more generic, because it's just dealing with list of edges rather than dealing with specifically A, B, and C cases. Now I want a pointer. That's the one. Yeah, actually, right first time. Yeah, I want a pointer that where I can change where it's pointing, but not change what it points to. There we go. That's right. Okay. And I think I put this out that I always wanted the neighbor's surface normal to, yeah, that's right, yeah. Yeah, I always wanted, in the event that like you can't find a good average between our polygon and the neighbors, you actually want to use the neighbors, because that probably means they're back to back and you want to be pointing in their direction before you're kind of crossing it over into their space. It'll still probably break everything because there's no handling in the, there's no specific case handling for that, but it'll sometimes do what you want. Okay, so we've averaged it, that's fine. And then we're going to do a cross product of yeah, the normal, and then the averaged surface normal, and then we're going to write that to the face exit normal. And then we're going to normalize it in all cases. Okay, that might work. Who can really say? Well, it didn't crash. So next up, let's actually export that information. It's going to be like this one again. The header of its edge exit normals, that's what it's called. Edge exit normals. need that anymore. Oh, actually, I can simplify this a bit because I can. Yeah, I can use this instead. I can just. I was already doing that. Ah. I don't think I actually called them. Hang on, I'll go back to the navigation mesh file. Oh, they're still called edge exit normals. That's fine. I'll keep that in then. Let's rename them for consistency there. Now we can get rid of the inner loop by doing this. Yeah, very nice. Get rid of this conditional. And just do that. And then we'll want a remapping after this as well. The footer of its edge exit normals and the header of its edge exit normal remappings. My God, what a mouthful. Edge exit normal remapping. Too many words, man. Okay, let's see if that works. Didn't like that. Let's see what they actually built, because it might be more obvious what went wrong when we have a look at it. Again, I'm pointing to the remappings rather than the normals themselves. There we go. Same mistake I made earlier. Glad to see I learned nothing from it. Okay, looking good. I can't really verify these are correct until I see them in engine, so let's carry on. And the final one is the final one I don't think I'm going to be storing. It's basically it's something we need for some of the collision checks, and it's so if you have a triangle like this, you have kind of like a plane here representing kind of like the boundary you can cross to exit that triangle. You have one here representing that, and basically it's the normal from this point up through here. So it's the edge exit intersection normal, I think is what I called it. It's just gibberish. Not even I know what any of this stuff means anymore. So to calculate this, I'm going to have to do something vaguely similar to what I've done here. So I think I'm going to reuse this. Yeah, I'm going to reuse this. And so I think how I was calculating this before. I think it's just the cross product of these two planes. I think it is. We'll find out. So previous edge exit normal. Ow, that's starting to get quite painful to say. There's just too many words there. And we can get rid of that. Don't need that. But we're keeping that. Yeah, that's right. There we go. That's right. And then we're getting the next one here, which is going to be like that, similar but slightly different. And then I'm just going to get rid of all of this. And we're going to copy the next to the previous. Okay, and now we need to calculate the cross product and normalize that cross product and write it out. So I need to write a header for these. I'm gonna have to look at what these are called again because I don't remember. Whatever I called them was way too long and complicated. So we're finished writing its edge, exit, normal remappings, and now we're writing the header of its edge. What do we call them? Edge, exit, intersection, normals. Edge, exit, intersection, normals. I'm going to have to look that up in a second because I've already forgotten what on earth it's called. There's that old joke that there's only two things that are hard in computer science, like cache invalidation and naming things. And it's definitely true. And that joke is like probably older than I am. So you read things like, I've only read excerpts from it, things like No Silver Bullet, which was written in, I think, the 60s. And so much of it is still true today about software development. I'm like, shouldn't have been that smart that early. Okay, edge, exit, intersection, normal. Yeah, there we go. Okay, so this should be relatively easy. So we just need to do a cross product between the previous and the next and write it to the result and then normalize it. So at which point we should be able to loop over the... No, I'm not going to loop over it. I'm just going to put them out by hand. I'll probably save like about 2 nanoseconds over this code's entire life. Okay, what did that output? Those look vaguely plausible. They're pointing upwards. That's a good sign. Okay, so now we need another kind of like remapping sort of table just to take that big long list of vertices and make them point in the right directions. If I wrote the photo of edge, exit, intersection normals and intersection normal remappings. Yeah, I think that'll do. That should work. Come on. What we got? Okay, that looks good. That's good. I wonder if there's a better way of doing this. I wonder if like C supports like jagged arrays. I don't think it does, but it might do now I've said that. Oh well, this will work in any case. So now we just basically need to write the final chunk of code that basically puts this all together into a struct and gives us access to it. So what did that used to look like? Don't put a breakpoint on. What does that even mean in this context? Yeah, it just looks like that. That's fine. That's good. So that should go in there. And we're going to need the name of the thing we're creating. And then we just need to work our way through this type and make sure we output something for each one of them. So I'm just going to extract the names out of this only, just so that we should be able to work through these pretty easily. So first of all, we have the count, which is the number of polygons. So that'd be faces. Yep, that's the one. Okay, and then we have the vertex counts. So that's going to be that vertex counts probably. And because we're using the names again, we need to copy those over. Let's just have a quick check and make sure that we're good up until that point. Just make sure I'm not barking up completely the wrong tree for a copy paste this pattern about 15 times. Oh, missing field neighbors initializer. That's fine. That's fine. That's actually good because that's the next thing we're going to put in. Yes, there we go. So we're starting to fill all these in. So I think it was neighbor remappings. Did I do that? Did I never output in the, hang on. I never did remapping on those, and I really, really want to do remapping on those. I think. Yeah, I do. Where's an example of some remapping code I've written? There we go. This would be perfect. This is exactly what we want. And the header of its neighbor remappings. And then let's go find wherever I've declared this, because I'm now declaring further up. And then write another neighbor remappings. And yep, that should be good. Not multiple by 3 because these are indices, not maxes of vectors. Okay, that should be good. Oh yeah, helps if you actually type the right thing in here, doesn't it? Index. And these are now neighbor remappings. Okay, we're getting closer, we're getting closer. What's it saying there? Let's just go through to where it's the code's complaining about. This looks slightly different to this. What's different about this? Let's put them side by side and see if we can spot it. Ah, we called one of them edge neighbors, which I guess isn't wrong, but it's not what we called it further up. Okay, that's good. We moved on to vertex locations. So now we should be able to use remapped vertex locations. Navigation mesh, vertex location, remappings. Now missing surface normal. Oh, did I call it surface normal rather than surface normals? My bad. Mesh surface normals. I don't remember if I added another name on the end. If it crashes, we know I didn't. Oh yeah, I want to do a parallel build really because I changed the header file. Come on, build. Faster, go. Okay, that's pretty unlikely I did that. Given nulls coming through, that probably means it ran off the end of an array. Oops. Okay, now we're up to edge exit normals. Almost there. Navigation mesh, edge exit normal remappings. Yeah, because that's another one that got remapped. Basically, if there's one per edge or vertex, they're kind of remapped, so you can quickly go from like face free to the exact data inside it. Edge exit intersection normals. Edge exit intersection. And then finally the edge coefficients, those are also remapped. Edge coefficients, that's what it's called. And then we need one more pair of names, and that should get us a completely initialized struct. Should. And now what do we have? Edge of coefficient. I called it coefficient remappings, didn't I? Slightly strange rule in English where you can only really have one plural in a term. Bit weird, really. Okay, that built hasn't quite worked. By the way, that I didn't remove the gravity, so it's still just falling, but it's just disappearing into the floor. That's great. All right. Let's try and figure out what I've done wrong. Let's go through to navigation mesh. So here's our layering code. So yeah, so we have a face, we should have our valid locations. Let's just temporarily clamp this down to 1. Okay, so we've got at least a couple that look very, very, very wrong. So let's oh, I think I know what it is. I haven't multiplied this by 3. Hey, that's looking a bit more plausible. So next up, why is it only like 1? Does it match up with somewhere in the scene? I did re-export this, didn't I? Let's find out. Yes, I did. So why is there only 1? Let's have a look in the... we can probably get rid of these now. Pretty confident these seem to be working. Movie theatre, and with the exported thing. How many... Where's the nav mesh? It's definitely it's definitely exporting 7. So why is it only drawing 1? That's definitely a correct coordinate. There's something wrong with our other code in here. So let's take a look at what code it actually generated for, say, the vertex locations. So if I go to the vertex counts, we've got the remappings. So look at the vertex count. So they right, yeah, they look right. And then we've got the vertex location remappings. Again, those look right. Whether they actually are is a different matter, but they look kind of right. is it only drawing one? Why is it only drawing exactly one? Why would it be doing that? I mean, the only reason I can really see is that... Let's make it error if there's more than... Let's just check. Is there only one in here for some reason? I need to import the error header. Okay, there's definitely more than one coming in here. Are we ever working on one that isn't the first? Yes. Okay. And are we ever working one that isn't the first and it has at least 2 vertices? Yeah. Okay, so they should be drawing. Why would they not be drawing? What's special about these? Let me just rebuild again. What's special about that first polygon? It doesn't apply to any of the others. What's special about it? What happens if I delete it? Let's just try deleting it, see if that fixes something. It's possible one of those loops is incorrectly kind of like, because we've got a lot of sort of stateful loops, so one loop passes to the next. That's interesting. That's not right. Well, I am pretty close to being out of time. In fact, I am out of time, so I have to stop there with everything broken. I hope you had a more successful day than this, and thank you very much for watching. Have a great Saturday.